So, good evening all. Welcome. It's 7:30 on Friday, May the 6th, 2022, which means it's time for another meeting of the Royal Astronomical Society of Canada, Ottawa Centre. Next slide, please. Usual things, we are recording the webinar for posterity, and it will be available on our fabulously provisioned website at ottawa.rasc.ca. If you wish to bring forward questions, please use the Q&A and they'll be transferred to the speaker. The chat box is for comments only, but will not be monitored or responded to. Raise your hand is disabled and not even worth trying. Next one, please. So tonight's program, you will note perhaps a change from the agenda as was initially publicized. The response in terms of contributions this month was just blowing everything out of the timeline available to us. So the presentation by Bob Olson, which was to be offered regarding the family Cassini, we'll get that next month. So meanwhile, you've got me introducing Mick Wilson. Dave Chisholm will do his regular Ottawa Skies this month for May. We have Ethan Siegel as our guest speaker, who will be talking about an instance of amateur astronomers actually doing big data science. And this is regarding the great mosaic of the Lesser Magellanic Cloud. So I'm looking forward to that. Pierre's going to be looking at the prospects for the Tel Herculids at the end of May. Usual break. Then we get onto the observational side of things. Brian McCullough is going to review a presentation he did a few years back, animating the sunrise at Sinus Iridum, last month's Lunar Challenge object. Then we get into the observation reports, and we do have a long list of observations for this month. Then Oscar's monthly challenges, and our closing out announcements, including the fact that we are going back to live star parties at Carp, and Andrea will have more on that further down the program. So Dave, next please. 2 new members this month, Benoit and John. If you're online with us, welcome. And we're waiting for you to volunteer to do a presentation. 23 total members so far in 2022. Next, please. No members in the news this month, and I should have taken those out. Silly me. Usual spiel for those of you who are thinking of joining or questioning the value of your current membership with the RASC. As you can see, the prices there are not insignificant, but we believe you do get your value for money. Next one, please. Normally, you would have access to both the Ted Bean Loan Library and our physical book library at the Canadian Aeronautics and Space Museum. COVID being on the wane, maybe within months, we might be able to get back to those. But meanwhile, members do have access to the Fred Lossing Observatory, about 40 minutes outside town from downtown Ottawa. You also get participation in the various RASC observer programs and the certificates that derive therefrom. You also get various print publications, Sky News bi-monthly, the Quarterly Journal, more academic in its presentation, the Annual Observer's Handbook, much respected all around the world, and of course our own Ottawa branch newsletter, Astronotes, on a monthly basis. My usual plug, to me, as someone that's come in from outside Ottawa in recent years, what I've found the most beneficial aspect of membership of RASC is the people that I am able to interact with, and that includes not only the members, but also the guest and invited speakers that we have at the meetings. And I just find that invaluable and hope many of you do as well. Over to you, Dave.
Okay, folks, let's take a look at the Ottawa skies for May. I'll first of all look at the phases of the moon. May 16th is our full moon. It was known by the early Native American tribes as the flower moon, because this is the time when spring flowers appeared. The moon has also been known as the corn planting moon and the milk moon. You notice the moon is a funny color on the 16th. Well, we are blessed with a full lunar eclipse, and it's at a decent time as well. So it starts at 9:32 on the Sunday and reaches maximum eclipse on Monday morning at 12:11 a.m. So that's something to look forward to. That's not this weekend, but next weekend. So we'll have maybe a few tired students in school on Monday morning after they stay up to watch the eclipse. We have the Herculids meteor shower, peaks on May 6th and 7th. It's capable of producing up to 60 meteors per hour. The show runs annually from April 19th to May 28th. So it peaks this evening. The waxing crescent moon will set early in the evening, leaving dark skies. It should be an excellent show. Next one we have is the Tel Hercules meteor shower. And Pierre Martin is going to be speaking about this in a little bit, so I'm not going to speak too much further on it, except it could be a spectacular show this year.
Dave, I can't see your screen at the moment. I see you, but not your screen.
Oh, you're not seeing my slides?
Yeah.
Okay, sorry. I'll try again.
I was seeing the slides.
Okay. My mistake.
Okay, you can see the slides, okay?
Okay, got it.
You got them now? Okay.
Yep.
Yes.
Okay, so there's the Tel Hercules. Sun rise and set. You can see that the days are getting longer as we move towards the longest day of the year on June the 21st. Mercury is not visible. It's sort of rising and setting with the sun. Venus is visible before the sunrise. Mars is visible before the sunrise as well. Jupiter is visible before the sunrise. Saturn is visible. Everything is visible before the sunrise pretty well. Except Uranus, it's visible before the sunrise, second half of the month. And Neptune is also visible before the sunrise. By the time August comes around, late August, we'll start to see some of the planets up in the evening sky. And this is our cartoon of the month. Thank you. So I guess I'm speaking to the first one here, Mick?
You're free and welcome to speak to all of them if you wish.
Okay, I could certainly. So right now we have some open positions where we're seeking some volunteers to fill those positions. The public outreach coordinator is the person when we get a request for doing some sort of astronomy outreach in the Ottawa area. This is a person who contacts the various people to coordinate these things. So it could be a request that comes in from the scouts or guides, or it could be various other organizations that would like to have some stuff on astronomy. And that is the role of the public outreach coordinator. It's not too time consuming, but you just have to be available and sort of have your finger on the pulse of the Ottawa Centre to know what members are available to assist you with that. The hospitality, this one is looking after the tea and coffee and goodies at the end of our meetings when we move back to the Aviation and Space Museum. I don't expect we'll be moving back there until the fall, but if you think that's something you would like to do, please speak to us. And the other thing is we have one more position that for the national representative, sits on the National Council, and we have one person right now. We need a second person. So if that interests you, please reach out to us.
Yeah, and I can speak to that one, Dave. I am the current solo representative for Ottawa to the National Council. Their quarterly meetings, generally about 2 hours in extent on a Sunday afternoon. It is not an onerous job. It depends on how politically motivated you are. There are a lot of issues that are dealt with at national level that are a little bit hard to, shall I say, mesh closely with the day-to-day astronomy that we as members like to do. But on the other hand, they do cover crucial things like the structure of the bylaws, issues such as insurance for star parties in the sense of liability that each centre has, prospects for fundraising under various levels of charitable status for different centres. So yeah, please, if someone wants to come on as a second representative, take some of this hectic burden away from me, I would much appreciate it. Thanks. And that's for Jim.
All right. So tomorrow is International Astronomy Day. So all over the world, there are local amateur astronomy groups getting together and bringing astronomy to the general public. The idea being we want to create an interest in our hobby as well as science in general amongst the public, kids and adults alike. So the activity that I'm coordinating is a public star party that is in the parking lot next to Chapters at Silver City, which is on City Park Drive by the movie theaters there. We will be setting up starting around 8 in the morning, but officially the activity runs from 10 to 10. We had a rain date of May 8th, but it's looking like, knock on wood, it's going to be beautiful, clear, and sunny all day tomorrow. So if you have nothing to do either during the day or in the evening, and you want to have a look through some telescopes at the sun or the moon, or maybe even some other deep sky objects later in the evening, then come on by and pay a visit.
Pay no money. It is absolutely free.
It is absolutely free. That's correct.
Beauty. Thanks, Jim.
Thanks, Mick.
And next, please, Andrea.
Okay, hi. So I am just going to speak briefly about Artemis. And the reason is that the Royal Astronomical Society is partnering with the Canada Space Museum to promote these flights, these 3 flights that will return humanity to the moon. And next slide, please. The idea is that the Artemis missions will eventually set up a lunar gateway. That is, they will set up a gateway that orbits the moon and will receive astronauts. From there, there will be a human landing system, and eventually they hope to create an Artemis base camp on the moon. Next slide, please. And this first launch of Artemis 1, which will be an unmanned rocket ship going around the moon, will be launching really soon. It could be in May, it could be in June. This first mission will not have any humans, but the next mission, Artemis 2, is expected to bring humans and hopefully get back to the moon. Next slide, please. So in the hopes of trying to generate interest in looking at the moon, having young people show an interest studying the moon, the Royal Astronomical Society is promoting the moon and is encouraging everyone to attend a moon theme event. For example, you could attend International Astronomy Day. I will be there and I will have a lot of material about the moon. There will certainly be lots of telescopes there looking at the moon. If you cannot make it in person to the Star Party in Ottawa, the Royal Astronomical Society has a Shooting for the Moon webinar the evening of May 7th, and they will have one of the Canadian astronauts on their event. So you may see some announcements about moon, Artemis moon parties and star parties, and we all encourage everybody to spread the word and read about Artemis missions. There have been at least 2 or 3 articles recently in Sky News about it. And if you can't make it out tomorrow, you should sign up for the Shoot for the Moon webinar, and you can find details on the website, rasc.ca, and also on our Facebook page. That's it for me. Thank you.
Right, thanks, Andrea. So, with no further ado, I have got a misspelling there, and I do apologise to our guest speaker. I thought I'd corrected that. So, first off the blocks tonight, we have Dr. Ethan, or Ethan, I'm not sure how he prefers pronunciation, he'll let us know. Dr. Ethan Siegel. Those of you who use Medium or are readers of Forbes magazine will know his column starts with a bang, which is a smorgasbord of interesting astrophysics as it is evolving in the public domain today. Ethan himself is has a PhD in astrophysics and has worked in the industry, but now, not the industry, the academic domain, but nowadays he's dedicated to public outreach of science, physics, astronomy, and the story of the universe. He's here to talk to us tonight about an instance of where amateur astronomers in the Southern Hemisphere, which I have to emphasize is hugely significant and important, have been contributing to a big data science project. And this is regarding the Great Mosaic of the Large Magellanic Cloud. And so, with little further ado, I'm going to pass across to Ethan and just point out that, like me, he was once a high school teacher, but got better, and that he's also a fabulous dresser, just like me. So over to you, Ethan.
All right, thank you. I just need a little permission from you to share my screen. And I think you gave it to me. So here we go. Hopefully everyone can see my slides now. Yep. And it's not, oh, right. Awesome. I got some thumbs up there. Thank you for that great introduction, Mick. My name is Ethan Siegel. He is correct. In 2000, 2001, I was a high school teacher, and I'll just, share with many of you, I'm sure many of you know, if you have a job that isn't the thing you really want to keep doing, there's nothing like that situation to make you think, what do I really want to do? What do I want to do next? What do I want to do instead? And for me, that was go to graduate school, get my PhD, and study theoretical astrophysics. And over the last 20 years, I've not only done that, I've been fortunate enough that people seem to like the way I teach and communicate science to the general public. So thank you for inviting me here to RASC Ottawa, and I'm pleased to be speaking to all of you. So as Mick introduced you to, you mostly know about the Large Magellanic Cloud, that there is a gorgeous object out there, the LMC. This is a big deal, right? The LMC is the closest relatively big galaxy to the Milky Way that is distinct. It is outside of it. If I said, what are some stats about the LMC? It is about 165,000 light years away. It is the fourth largest galaxy in the local group, behind Andromeda, ourselves, and Triangulum. There are approximately 1 billion stars, maybe even more, in the LMC. It's also big on the sky. If you said, I want the half-light radius of the LMC, that's a thing astronomers use, half-light radius, that takes up about 5 degrees on the sky. If you said, I want to get all the light, all the stars in there, you have to go about 10 degrees in either directions. That's about 100 square degrees on the sky, or, if you round it off a little bit less, but that's pretty big. Now, this picture that I showed here is from the European Southern Observatory, and it's a professional shot. And there are better professional shots out there. For example, here is one that gets lots of detail and star-forming regions and young star clusters. This is from the Digitized Sky Survey 2. And you could say, oh yeah, well, I've heard of this telescope Hubble. Did Hubble ever look at this? And the answer is yes, absolutely. Hubble has taken a great look at the LMC. Here's a little piece of the Hubble view of the LMC. Now, unfortunately, the LMC is pretty big on the sky compared to Hubble's field of view. So, you know, when you want to say, I want to grab a wide field of view, Hubble and James Webb after it are not good for that. This is where I think amateur astronomies come in. Amateur astronomers, what can they do? As an amateur, what can you do that the pros either can't do or won't do? Well, a huge thing they can do is wide field imaging, right? Professional astronomers tend to generally go narrow and deep, or if they go wide field, they do it in a short period of time because they're generally looking for changes, for transient events. So you can only go pretty shallow. But as an amateur, you can do wide field imaging. You can do it in many different wavelengths. You just attach whatever filters you want. These could be photometric filters like red, green, blue, you know, maybe even a little into the infrared. We have a series of filters you can get. You can also do spectroscopy. You could say, I'm going to put my H alpha filter or my O3 filter or my sulfur 2 filter, right? Wherever you can have a strong emission line, that's a great thing you can pick up as an amateur. And amateurs have this benefit that they have time. You can observe the same area of the sky over and over again. There's no one breathing down your neck, clamoring for your telescope time. This is your stuff. And so you can take time to create mosaics, to hone in real deep on a region of the sky, and to tease out these faint features. So let's compare what this team did. Like you were told, they're from Chile, they're in South America, so they get a view of the southern skies. This is that wide field professional view of the LMC. Now, I'm going to show you they did it in two ways. They took an RGB photometric view where you observe in the red and the green and the blue, and you make as close to a true color image as you can. This is what the amateur RGB looks like. So professional is, you know, this one, amateur is this one. Looks really good. There are a lot of features here that you can see. In particular, you see these pinks and these blues, right? In addition to the stars, and you can make out the colors of some of the stars, like some of these you can see like, oh, I see red giants, I see bright blue stars. But you also see these pink areas and these blue areas, and these are emission and reflection nebulae, right? The emission nebulae look pink because they emit in H alpha. That's that Balmer transition where you say, okay, we're going to drop from n equals 3 to n equals 2 in the hydrogen atom. And, you know, okay, that's H beta. But okay, great. So you say that's the Balmer alpha line, and there it is. RGB, that's the red. Then you say, what's the blue? Well, when you form new stars, you get these hot blue stars and they reflect off of the dust. So those are reflection nebulae. So you can learn a lot just from looking at RGB. But what really impressed me was all the time they spent doing spectroscopy. And so they assigned, we're going to look at hydrogen and assign red to hydrogen. And we're going to look at oxygen, doubly ionized oxygen, and we're going to assign green to oxygen. And we're going to look at sulfur, and we're going to assign blue to sulfur 2. And here is this same region spectroscopically. And I looked at this and I was blown away, right? You can see in the plane of the galaxy, even though we think of the LMC as being pretty irregular, right? It has that main swath through it, and that's where most of the hydrogen is, right? You can see, oh, here's the sulfur, here's the silicon, right? Making these beautiful colors. Here's the oxygen. One of the things I love looking at is, you'll notice on the left side of your monitor, there's this big swirly region. It looks like the messiest place of all in this. That is the Tarantula Nebula, also known as 30 Doradus. It is the largest star-forming region in the entire local group. Even though the LMC is just like 1% the mass of the Milky Way, and we're less massive than Andromeda, the largest star-forming region in the local group is right here. There is a star cluster at the heart of this that has an estimated 400,000 new stars. This has been observed in detail. Here is the Tarantula Nebula as seen by Hubble. Pretty impressive. And you can see that glittering, it's actually two merging star clusters in the center of it. But what blew me away is the original images of this that the amateurs took are more than 10,000 pixels on a side. This is enormous. This is an enormous mosaic. So I can zoom in on the Tarantula Nebula, and here's what the RGB of the Tarantula Nebula looks like. And this is what the spectroscopic view of the Tarantula Nebula looks like. And again, this just sort of blew me away when I saw that this is created by amateurs. Like, let's remember, Hubble, amateur RGB, amateur in spectroscopy. Like, this is just awe-inspiring to me that you can do this with, believe it or not, a 6-inch telescope, a 16-centimeter telescope. And they were able to do this because of the power of time. The amateur group is called Ciel Austral, and their website is cielaustral.com. And it took them 18 months to take the data for all of this. Just with one 16-centimeter scope, right? That's about this big. They got a total of 1,060 hours. And they did this cooling their instruments down to about negative 25 Celsius. I think in Canada, you're all on Celsius, so I don't have to give the American Fahrenheit to you. But I do have to stop saying American because no one in Canada likes that. So 28 hours each went to the red, went to the green, went to the blue filters in photometry, but 25 and a third hours, 25 hours and 325 hours and 20 minutes went to each of H alpha, O3, and sulfur 2. And that was how they were able to get this fantastic spectroscopic data out of it. What kind of milestones did they achieve? First off, this is the longest exposure record for a single object in amateur history. Actually, I'm pretty sure it's in professional history too, because the deepest image we have of the universe is the Hubble Extreme Deep Field, which has a total of about 23 days of observational data. But 23 days, if you say 23 times 24, that's only a little more than half of 1060. So this was observed with an amateur telescope for about twice as long as the Hubble Extreme Deep Field. They were able to see the elements that are present inside, right? You trace hydrogen, you trace O3, you trace sulfur, and this is ionized sulfur. This tells you information about the star formation history, particularly the recent star formation history of what's happening in the LMC. And that data, that spectroscopic data they have of the LMC, yeah, in parts of the LMC where Hubble has looked, for instance, or the Gemini telescope has looked, right, 8 meters, right? Well, that's better than what an amateur can do with a 6-inch scope. But in the regions that haven't been imaged by the pros, this is the best data set out there. So this tells us that many details are present in the various parts of the LMC that were never revealed before this image at the resolution and at the depths that the Ciel Austral team obtained. And, you know, look, you're an amateur astronomy group. I just wanted to let you guys know, let everyone in the club know, with the right target and the right equipment and, you know, a little fortuitousness from the skies, this record could be yours. The record of the longest exposure record for a single object, there's no reason you can't break that. And I'll let you know to end this that there is a full resolution, and these are enormous versions. Like I said, these are over 100,000 pixels total, more than 10,000 by 10,000. But the full resolution, enormous versions are available at the Ciel Austral website, /gallery/photo95.htm. But here is, again, just a nice little region of space where you can see an RGB on the right. You have the blue reflection nebulae, you have the red emission nebulae. But then when you look in the gas, when you look in spectroscopy, you can see these interesting knotted features, and you can see like, ooh, look at all the sulfur down here, and look how there's not a lot of oxygen, but then look how there is oxygen up here. It's really a wonderful, fascinating project. And I think I just wanted to make a quick little presentation to you to show you what we had going on, and to show you what you know, a group of people very much like you who just happen to be in the Southern Hemisphere. And look, I'm not going to lie, in Chile, it helps to have still, dry air and to be up on a plateau that's a few thousand meters above sea level. Like, they have some pretty good conditions for observing over there. But also, this was fascinating to me. This was fascinating, and I was very, very honored that Mick asked me if I could put something together to share this with all of you, because, you know, how wonderful is this that we now have, thanks to one amateur astronomy group, we have a better image of the full Large Magellanic Cloud, both in RGB and in a variety of elements, than we've ever had before.
Thank you so much, Ethan. That was brilliant. Yeah, you're right. The Chileans have it lucky. The LMC's circumpolar, they had all the opportunities to garner those hours without worrying about seasonal drift and so on. But still, the scope of the effort, the coordination, and the results, to me, they all speak for themselves. Years ago, I paid a visit to Mount Stromlo Observatory outside Canberra before it burned down. And someone there pointed out that if the Tarantula Nebula was at an equivalent distance to the Orion Nebula, it would span greater than a full moon in the sky. Imagine living on a planet with a view like that. Anyway, I like always to have a question for our presenters, and I hope there are others going to pop up on the screen as well. If you were to propose something like an equivalent target for a coordinated, long, strategic effort like Ciel Austral did for the Northern Hemisphere, for this latitude, what would come to your mind?
You know, what would come to my mind, because when I think about this, is my no-brainer thing is to say, well, what are the good Messier objects? What are the good Messier objects that are really only available to people in the far north? Because, you know, that's one of the benefits of where you are, is you say, okay, if we're going to look close to the zenith, what gets up there, particularly during the months when skies are clear? And so I'll say, you know, there are some pretty high, guys, you'll tell I'm a theorist as I don't remember which one's right ascension and declination. I think it's declination. It's declination is what we want. But I would say, you know, if you want a globular cluster, take a look at something like, you know, M15. If you want something like you know, objects that are in Ursa Major, like Messier 51, although that one's been imaged a bunch by people, or Messier 101, which hasn't been imaged as much. That one's really, really fascinating. I am always partial to, I don't know how many of you are familiar with it, because to me, you know, it's one of those objects that probably should have been in the Messier catalog, but I love these, like the needle galaxies, the ones that are like edge on, that are relatively close, but that, you know, because they're edge on, they're a lot of them weren't spectacular to Messier, and they didn't get cataloged like that. So those are some of the ones I like. I'm trying to remember the phone number of the one I'm thinking of. I think it's not called the Needle Galaxy, but I think it's NGC 5866 in Draco. That's the one I'm thinking of. It's about 50 million light years away, but it's, you know, but it's close to both M51 and M101. It has a high declination of, I think, plus 55, but it also has this just really nice extended dust disk in it. So if I were going to pick one, although it has been seen by Hubble, I don't think that there has been a nice spectroscopic map of it. And it also has this nice property that its apparent size is, you know, relatively on the smaller side. So if you can take a, you know, maybe a more impressive telescope and just put the right filters on it, you can really start to see some of the spectacular features inside. And that's your trade-off. You can either go close and get a small thing, or you can go far away and get a larger thing and get it in your full field of view. So, you know, I don't know if that's the best call, but I've always been like impressed by that, thinking like, oh, you know, this one should have been in that catalog. This one should have been in that catalog. Messier was like, oh, we'll never confuse that for a comet, so I won't put it in my catalog. But, you know, I think this is a very impressive object.
Thanks again. So yeah, we have one question from the audience. I think it's pretty much the same question. What's the next target that needs attention like this? So I guess if you're going to answer that and take the brakes off the Northern Hemisphere,
you know,
what sort of answer might we get?
The difficult thing about what needs it is there are actually a whole lot of objects that are pretty close by that haven't been imaged in great detail. But the ones that haven't been imaged in great detail, they tend to be either the ones that are in the Southern Hemisphere predominantly, or they're the ones that are in the galactic plane. And those generally need infrared astronomy. So you could say like, hey, are there any close, you know, giant elliptical galaxies? Yeah, there are. If you are familiar with the Maffei galaxies, named after Paolo Maffei, he's the person who pretty much invented infrared astronomy in the 1960s. And when he looked in the galactic plane, he found a number of galaxies, including Maffei 1 and Maffei 2. One's a big spiral, one's a big elliptical. They're less than 10 million light years away. They're right about 10 million light years away. They're about the same distance as M81 and M82. But whereas M81 and M82 had been observed by everyone and their mother and their grandmother, Maffei 1 and 2 really only accessible to infrared observatories. Most of us, including me, don't have access to infrared observatories, but that's really where we need it, is these galaxies, these objects that are kind of stuck in the galactic plane. But if you wanted to say, you know, where where would be an interesting place to look? I mean, if you're going to do spectroscopy, I would say any emission or reflection nebula, anywhere where star formation has occurred recently, these could be fascinating things. And if you aren't afraid of a crowded field of view, you might even want to take a look at some relatively recent, in the last 2,000 or 3,000 years, supernovae that have historically occurred in the Milky Way. These are things that every time there's a new image of one of these old supernova nebulae, supernova remnants, or anytime there's an image of something like the Wolf-Rayet stars that exist towards the galactic center, I get really excited. So I don't know how your club is doing as far as aperture fever goes. I'm maybe not the best person to ask about that, because although I do have a 10-inch Dobsonian at home, almost all of the night sky observing I do is with a 3-inch pair of astronomy binoculars that I just have a tripod and a mount, and I just love looking around and seeing what's out there. But as far as deep sky objects go, supernova remnants, hot young stars that are on the outskirts of star forming regions, and galaxies that don't get looked at very often. Those are my favorite choices of where I think you could really do something phenomenal.
Thanks. And we have one more question, and then I think it's time to close out. Joe Holmes is asking, says it's a great talk you gave. Thank you. Since they are not stars themselves, what illuminates the gases so that we can see them?
Okay, so it's kind of a misnomer to say it's not all stars themselves, because when you form stars, right, that's when you get the hot young blue stars, right? There's this problem. I think of it as the Blade Runner problem, right? You watch Blade Runner, there's this famous line where he's talking about the flame that burns twice as bright burns just half as long. And although that's true for candles, for stars, it's way worse. If you double the mass of your star shines about 8 times as bright, and its lifetime plummets. So you can say a star like our sun might live 10 to 12 billion years. A star that's 10 times as massive as our sun might only live 10 million years. And a star that's 100 times as massive as our sun might only live 1 million years, right? The more massive you get, the shorter a star's lifetime is, but the hotter that star burns. So as long as you're emitting enough radiation that hydrogen can become singly ionized, that's when you get an emission nebula, because you kick electrons off of hydrogen atoms, then the electrons come back down and combine, and they emit as they cascade down in energy level. When they go from 3 to 2, that's when you see that red, that pink, that 656 nanometer line. And then you say, okay, well, what about oxygen? You got to get hotter to doubly ionize oxygen. But if you doubly ionize oxygen, which happens at about 50,000 Kelvin, as opposed to like 10,000 Kelvin for the H2 line, then you start making that green oxygen line, that green O3 oxygen line. And that's why you're able to see oxygen. And then sulfur too, I believe, is somewhere in between. But this is why it's interesting to look at places that have recently formed stars. That's why I like either the areas around very hot stars where new stars have formed recently, or I like supernova remnants because they've gotten up to those temperatures and they have shock heated the gas. Or I like entire galaxies because galaxies always have star forming regions. I didn't mention the red and dead ones, so take the dusty ones. The dusty ones always have star forming regions in them, and that's why it's fascinating. But yeah, you do need that energy to come from somewhere, and unless you have something like, oh, here's a dusty galaxy and here's a dusty galaxy and they're colliding, yeah, that will heat up your gas gas too, but that's also going to trigger new star formation. So you basically want to look, where are the young stars, or where were the young stars very recently? And that's where you're going to see these, to me, these really fascinating features like emission nebulae.
Beauty. Ethan, I'm looking forward so much to dragging you back here for another presentation sometime in the future. I think you've done a sterling job. Round of applause. And hope to see you again. Thank you.
All right, thank you. It's my pleasure to be here.
And Dave. Our next presenter is Pierre Martin. Those of you in the club will well know, but perhaps some of you watching don't. Pierre's been observing, he's our meteor nut, our meteor nerd. He's been observing for over a decade and reports into serious meteor societies like the International Meteor Organization and the American Meteor Society. He enjoys meteor photography, and we'll see some examples in the observations later on, and exploring the deep sky with his telescopes, participating at local astronomy club functions like International Astronomy Day tomorrow, and sharing his passion at public events, and has been and is much appreciated as a regular presenter to RASC Ottawa. So tonight, he's talking to us about the prospects for a possible outburst with the Tel Herculids on the night of May 31 this year. So over to you, Pierre.
Thank you. I'm just going to get my share screen set up. Thank you.
Thanks, Whitey.
Okay, good evening, everyone. And I'm going to be talking about this, possibly this special meteor shower coming up at the end of the month. This has been an event I've been looking forward to for many, many years. In fact, if you were to ask me 10 to 12 years ago what the year 2022 would make me think of, this would be it. This is the first thing that would pop in my mind. Just because there's a very real chance that this could be a spectacular meteor shower, unusually active, and either a strong outburst or possibly a meteor storm.
Pierre, you've got to choose a theme box that's covering your screen.
Oh, thank you, Dave. I'm just going to take a look here. You just see if I can get rid of it. Okay, does this appear better? Because I don't think I see.
Yeah, it's covering up the screen from our perspective.
Okay.
Maybe it's in your background.
Let me just try a switch. Is this no, this is not going to be no, I'm not too sure what is covering the screen because I am not seeing this at my end. Is the screen completely hidden?
Good chunk of it is, yeah. Why don't you just go back to the edit mode? Just get out of the full screen mode.
Okay, let's try that. And let's
That's not too bad.
That's good.
That's good.
Yep, that's good.
Okay, okay, great. Now I'm just going to see. I will have to switch slides manually, I think, this way. Oops. Okay. Okay, there we go. Okay, so let's start by exploring the conditions that might rise to a very spectacular meteor shower by looking at the source, which is 73P, Schwarzmann-Wachmann 3. This is a relatively small comet that's a member of the Jupiter family of comets. Has a period of 5.4 years. It is relatively faint. And during several returns, it was actually unnoticed many years. In October 1995, Schwarzmann-Markman 3, I'll refer to SW3 for short, it unexpectedly brightened from magnitude 12 to 6.5, which is a nearly 400-fold increase. Really a spectacular, completely unexpected brightening. It broke into several fragments on the autumn of 1995. This was a dramatic increase in the comet's intrinsic brightness and a massive expulsion of the dust. The year 2001 and 2006 returns featured multiple fragments and again, some more comet breakup. And the next perihelion is on August 25, 2022. On the right side, here you can see this is the Spitzer telescope, an infrared view that captures the comet and several of the fragments. So 45 of the 58 catalog large comet fragments in 2006. And each of the fragments, again, continue to fragment into further pieces. And also the dust trail is clearly visible along the trail of the fragment comets. And on this view, we see again in 2006 some close-ups on a fragment B and fragment G. Those two chunks continue to fragment once again. And here I'm going to try and see if this is going to play. There's a really cool video by, this is basically a Hubble image made from 3 exposures over the course of 3 days. And you can see how the fragment B of SW3 basically had a massive breakup of different chunks, several dozens of the chunks that broke off from the main nucleus. So really there's a lot going on with this comet in terms of like a massive amount of dust expulsion. So now we'll talk about the comet and also the Tel Hercules discovery. So we realized back in 1930 that this comet, shortly after its discovery, that it was associated, or there was a good chance that it would produce a meteor shower that same year. So the radiant was predicted to occur in Hercules. So it was designated the Tel Hercules shower. And in more modern times, shower number 61 from the International Astronomical Union's Meteor Data Center. So what happened is on June 9, 1930, the date or the night of expected activity from this brand new shower at the time, there was a reported outburst in Japan of 59 meteors in 1 hour that was reported. And then again, on the following night, another 36 meteors within 30 minutes. So some pretty strong activity. So the only caveat with this observation is that this is the only known observation of that outburst. Elsewhere in the world, did not report any meteors or very few, and it was also a full moon. So there has been some debate over the accuracy or the reliability of this one single set of data that's known, but this is what we have to work with. In the years following 1930, Tel Hercules activity has been very sparse or even non-existent in most years. However, in more modern times or more recent years, the Tel Hercules have made a return. So using modern dust prediction models with from the comet SW3, the meteor dynamicists were able to predict some possible activity in 2011 and also again in 2017 from interaction by a dust trail that was known, that was produced in 1941 and also in 1952. They expected the distance between the trail and the Earth was thought to be very large, so very, very little activity was predicted. However, it was confirmed both years, mainly by the NASA camera network for all-sky meteor surveillance. They did detect low activity in 2011 and again in 2017. Individual meteors were captured in a tight area very close to the position of the expected radiant for 2017. And those were confirmed to be part of the 1941 dust trail. And again, there were several other, those colored dots you see around, scattered around in the sky, those were probably more diffuse member of the shower caused by perhaps more ancient dust trails or just general activity. So something indeed was happening. And although the rates were extremely low, they were able to confirm the timing and the radiance quite accurately. So this was boding quite well for the 2022 prediction. So let's talk about what causes a meteor outburst. So when a comet comes near the warmth of the sun, a little of its frozen nucleus sublimates, shedding clouds of dust and rubble. So the material gradually spreads along the orbit, and then it gradually diffuses away. This is due to the gravitational perturbations and solar radiation, mostly. Thin concentrated bands of debris exist within the much larger dust stream and typically concentrated near the parent comet. An intense shower will occur when the Earth passes through one. So meteor dynamicists have become quite good at predicting the Earth dust trail encounters, but there are some caveats. And one of the biggest caveat is the amount of data available. So in the case of a shower that has a lot of historical data, like the Leonids, we're able to be really good, very, very precise, like those intense outbursts in the late 90s and early 2000s that were predicted very accurately. This was mainly due to all the data available. But a shower that's much more obscure, where we don't know much about the comet or the dust trails, or we don't have a lot of historical observations to test out the models, then it becomes a little more questionable whether the predictions are going to be accurate or not. And a lot of times we can get the timing and the radiant in the sky quite good in predictions, but the rates, the zenith hourly rates, can sometimes be a hit and miss. So forecasting the 2022 Tel Hercules. So we have 3 independent meteor dynamicist models, 2 that suggest a direct encounter with the 1995 trail of fragments. So that's that trail that fragmented spectacularly, and that must be very rich in dust. While another model does not show significant activity. So there's some discrepancy happening. So the possibilities include, we could get a shower that's quite strong, an outburst similar in strength to the Perseids or the Geminids, or possibly a meteor storm outranking even the spectacular 2001 Leonids, or there could be few meteors at all. So there's a lot of different possibilities. Let's explore first the Jeremy Vaubayon model. He's a French astronomer and meteor dynamicist. He uses, basically in his model, he typically uses 2 million simulated particle ejections through many, many different revolutions of the comet over the past few centuries. And he uses different sizes of dust particles from 0.1 to 100 millimeter size. And typical ejection escape velocity from the nucleus of the comet is taken into account in the sunlit hemisphere, as well as a function of the comet nucleus properties and the size, the fraction of active area, and etc. Also particle size, ejection subsolar angle, and heliocentric distance. So all these things are taken into account in the computer model to predict where those dust trails are going to be moving in space. So in his case, for the 2022 Tel Hercules, the nodal crossing points of the meteoroids ejected from SW3 at all perihelion passages go back to 1801. His standard model shows that the Earth will interact with some dust, mainly from the 1892 trail and the 1897, so those are fairly old, diffuse low density trails, but his model here does not show the 1995 trail, not at all. So according to this model, there's no meteor storm or anything spectacular, possibly a couple dozen meters per hour. So why? Let's take a look at an article that was written in the RASC journal about a year or so ago by Joe Rayo. He analyzed the situation and tried to see if he could confirm Bayonne's prediction and to dig a little deeper into it. So he created basically a simulated trail using multiple sample comets in a software program. And he set this comet train in motion around the sun using the gravitational effects taken into account. So in his analysis, the Earth will arrive at the descending node of SW3 about 66 days before the arrival of the comet. And assuming generally that meteoroids are trailing behind the parent comet, we can conclude that the Earth will not interact the 1995 dust trail. It's going to be too far away. So again, this seems like bad news, right? But other model forecasts are a lot more optimistic. So Luthen is another independent meteor dynamicist, and he states the following: probably the best chance to see an SW3 display will come in 2022 when we pass the 95 trail at about only 0.0004 astronomical unit distance. It's basically, we're going head on into that dust trail. The display is especially promising. The disintegration of SW3 in 1995 should have introduced a lot of dust particles into the trail. Another independent meteor dynamicist, he says the following: the dust trail ejected in 1995 will approach the Earth as closely as 0.00038 astronomical unit in 2022. Meteors are due to this dust trail is highly expected. And in his graphic on the right side, Earth will be basically doing a direct hit with the 1995 dust trail. So we have very conflicting predictions. But even more tantalizing is Russian meteor expert Mikhail Maslov, who in his analysis, he gives the following with his model. For the given period of time, the basic model gives meteor activity with a zenith hourly rate max of between 600 and 700 expected. However, considering that in 1995, the comet 73P broke into several parts, the real activity should be 1-2 orders higher, up to 10,000 to 100,000 meteors on the ZHR scale with high average brightness. So this being the case, then we're talking about a shower at the scale of the 1966 Leonids, where we were getting about 40 meters per second. This is pretty intense. So there's another solution. In that same article written by Joe Rayo in the journal, he attempts to explain the discrepancy between the models. Why are there such differences? He found out something. Ejection velocity and the particle size is key. So ejection velocity is basically refers to how fast those dust particles are ejected from the comet as it runs around the sun. Standard dust trail models used by several meteor dynamicists assume a 1 millimeter particle size is ejected at about 20 meters per second, okay? During SW3's breakup, the meteoroids likely had a higher, possibly a much higher ejection velocity than usual. And this is because of that massive dust or that massive breakup that occurred in 95. But what's also different in this case, which is unique, very unique compared to other showers, is that the ejection velocity is negative. And by being negative, what this means is that those dust particles were ejected in the opposite direction of the comet's motion. So what this all means is that the particles and large particles from the 1995 breakup likely move forward of the comet and not behind it, like would be the case in with most other like normal comet returns around the sun, where the dust spreads out more evenly, more slowly and more evenly and behind the comet. So Joe Rayo's finding are in agreement with the more optimistic predictions by Luthen and also Hori. And as you can see on this graphic, the train of simulated comets are right in the middle of where the Earth is positioned at the descending nodes on May 31st. So what we can gather with the Tel Hercules. So here's a rundown. Earth has never interacted with this particular meteoroid trail before, and just how much denser the 1995 trail is compared to a standard dust trail is unknown. We just don't know it. It makes the predictions quite difficult. It could be at the low end of the zenith hourly rate. So assuming that the dust expulsion in 1995 didn't occur and the particles didn't shift in front of the comet, the low end would be about 14 per hour, a very minor shower. If we get a possible 10-fold increase, we get a shower that's pretty strong, similar to an excellent year of Perseids or Geminids. And if we get a possible 100-fold increase, then we get a meteor storm. So there's also a parallel to a well-known meteor storm that occurred, or a series of 2 or 3 different meteor storms that occurred in the 19th century, known as the Andromedans, caused by 3D Biela. And the upcoming situation for the end of May is more or less similar in terms of the distance between the Earth and the comet and the position of the dust trails. There is some parallel to the 19th century storms, but with one exception, is that back then, in the case of the Andromedans, the Earth reached the dust cloud behind the comet. The comet had already reached perihelion. In the case coming in at the end of the month, we're going to be ahead of the comet. So 2 different geometry. It's not quite comparable. There's some parallels, but we can't do a direct comparison between the 2. And the last point that's quite important is that these will be very slow entry velocity meteors, only 12.5 kilometers per second, among the slowest possible meteors. In fact, so slow that the Earth's gravity will actually give these meteors a bit of a boost before they burn in the atmosphere. So the particles, this could be good and bad in the sense that slow moving meteors are really beautiful to see. They can really be captivating, easy to photograph and colorful, but there's less energy when they burn in the Earth's atmosphere. So for a meteor, a slow moving meteor to appear as a magnitude 1, it would have to be a larger chunk particle. If the meteors are going to be very small particles, they may actually be too faint to see, or they would require a very dark sky to be noticed, or possibly only by radar. So that can be one factor here. But we have breaking news. So the first dynamicist that I talked about, Jeremy Vaubaillon, the French meteor expert, he took notice of Joe Rayo's article, and just about a month ago that I found this out, he revised his model. So his model was initially not showing the 1995 dust trail. It was showing a minor shower coming up at the end of May, some activity, but probably no meteor storm. But in his analysis, he rechecked and he confirms that Joe Rayo's finding has potential. And a higher ejection velocity brings the meteoroid further from the nucleus, indeed, and in front of the nucleus. And on the right side, you see the comparison that shows the difference between a velocity multiplication factor of 2 and 2.5. Typically, a comet that's not breaking up or doing any kind of special activity will normally eject particles at about a little over 1.0 multiplication factor. If we double that at 2.0, you notice on the right side, the trail from 1995 doesn't quite reach the Earth's orbit. We're just not quite there. If it's 2.5, it does reach. However, the comet gas production rate increased by more than an order of a magnitude during the 1995 outburst. In this case, this leads to an actual ejection velocity increase of 2.7. Even better news, it means that we're well within the 1995 dust trail at the end of this month. So this is really good news that bodes well to possibly having a strong shower or something really spectacular. So Bayonne concludes, an ejection velocity increase of a factor of 2.5 or more during the 1995 outburst of comet 73P is totally realistic. The 1995 passage will encounter the Earth on the 31st of May with a peak at 1 o'clock in the morning. So this is also very encouraging for us here in Ottawa or the region and North America, especially in the central United States, Eastern Canada, are well favored to see the peak if it occurs. And all the dynamics, I should note that all the predictions are showing the timing very closely. They're all around 1 o'clock in the morning. I think the latest one is about 1:20 in the morning. So they're all around that time frame, which is also very encouraging. Again, the velocity will be very slow. These meteors will stand out compared to the Perseids. There'll be very, very slow moving streaks in the sky. This makes the shower also hard to predict. If the particles hopefully are large enough dust grains, they should be quite visible. Other dust trails ejected from the years 1992 and 97 will likely cause 2 other minor outbursts. So observing the Tel Hercules, again, most likely time, do take note, the night of May 30th and 31st, so the evening of the 30th into the morning of the 31st, 1 o'clock in the morning is a time to view, Eastern time. Observing for at least an hour or 2 before and after this timing is highly recommended. As always with meteor shower predictions, there's no guarantee. So the timing, although the 1 o'clock in the morning timing is it seems very encouraging, there is always a possibility that the timing could shift a little bit behind or after this time. There's also another prediction for possibly an enhancement around 11 o'clock in the evening that same night. And the location of the radiant, despite the name of the shower called the Tel Hercules, the radiant will actually be located in Bootes, about 10 degrees north of the bright star Arcturus. And the reason for the name of the shower is that historically, the radiant used to be up in Hercules, and over time, over the past few decades, has migrated out into a position near Bootes. From Ottawa, the radiant at the time of the expected peak at 1 in the morning will be 60 degrees high, so more than halfway up in the western sky at the predicted time of the outburst. So as always with meteor showers, choose the darkest location possible away from sources of light pollution and an open view of the sky. Then all you have to do is simply sit back on a lounge chair and look up. Observers in central and western Canada will be hindered by deep twilight. So the best possibility would be eastern North America and central all the way down to Mexico. We'll have the best possible view in those locations. Also watch for Tel Hercules forerunners and stragglers on the night surrounding May 31st. And another really good news is that it's going to be new moon on May 30th, so no lunar interference to worry about. So whatever you do, be ready for surprises and possibly bad surprise. And some of you who were around in 2014 for the May camelopardalis will have memories of this event being something that was like highly publicized as going to be very spectacular, something to look forward to, and it was all over the news. And the shower was a bit of a dud. Like it was active in very low numbers. So the question begs, is there a similarity with that event, with what's coming up? Well, what I would say is you can't really compare the two. We know a little bit more about the comet SW3, the behavior that occurred in 1995, and that's where we're very hopeful. In the case of camelopardalis, we didn't have any data over the past. We knew very little about that comet Linear. It was a very faint, very little observed comet. All we had was the models predicting a very close encounter with a series of dust trails. Theoretically, there was a chance of a meteor storm from that event. But as we learned afterwards, those dust trails were mostly empty of dust or had very, very small particle size that weren't visible visually with naked eye. So as it goes to show, we never know what to expect with meteors. And this is partly why it makes observing meteor showers and studying them so exciting, because there's always something to learn from it. And even a negative result, even if the shower completely does not occur or it's just a minor activity, it can still give us something about the science of comets, meteors, meteoroids, and the solar system celestial mechanics. And just finishing those pictures on the right side, those, despite the May Camelot partlets in 2014 being very low rates, Ottawa's Raymond Dubois was able to photograph one of the few bright meteors that actually left a bright persistent train that you see on that little orange spot that you see on the right side on the photo. So again, I would encourage you to try to view the possible activity of the Tel Hercules at the end of the month. It could be spectacular. If there is a storm, this could be the best chance we have in our lifetime of seeing one, because not even the Leonids in the future are predicted to storm, I think, until 2098. So it could be a long, long wait before we see, or we may not see another known chance of a meteor storm. So good luck, and I hope to hear your results at the following meeting. Thank you.
Well, thank you, Pierre. And I've got a question for you. Is that good?
Sure, absolutely.
Okay, so Peter, excuse me if I massacre the pronunciation, Tumilty, is asking, is there a latitude where this shower cannot be seen? I am at 63 north, 68 west.
Latitude, the shower will be mainly visible only from the Eastern North American longitude. In terms of latitude, there's a much wider spread. So from the Maritimes all the way down to Mexico and Central America, and I think part of South America are going to be in good position. Other parts of the world, unfortunately, Europe, Asia, Pacific, Australia are not going to be in position to see the outburst, assuming that it occurs at the predicted time. So there's always a chance there could be secondary outbursts or enhancements around the main time or during the surrounding days that could well be visible in other parts of the world. So I would still make an effort to observe in case something happens, for sure.
Beauty. Okay, and score -1 for the Southern Hemisphere, but there you go. Thank you, Pierre, and looking forward to what might be some spectacular results. Thanks. And Dave, back to you.
Okay, this is the next slide, Mick, with International Astronomy Day. I think we've already talked to this.
Skip over.
Some more details. Okay. Oh, bio break. There we
go. Finally. Okay, so those of you who have been to our fabulously well-provisioned website know that the videos from each of these meetings are posted there. Rather than posting a whole 5-minute bio break, there's actually a bit of intermission. This month's trivia question is, where does the music and the animation for that intermission break in the videos come from? Hey Dave, shall we continue?
Absolutely. So I don't want to go to the next slide yet, though, because let's see if everybody knows the answer. Everybody's been racing to the website to try to listen to the intermission music. Any guesses, folks?
Nope.
Nope. Okay.
Okay, next slide. It is from the intermission scene from Monty Python and the Holy Grail on the Bridge of Doom. All of that. Anyway, so over to Brian and his sequence of sunrise at Sinus Iridum.
All right. Can you hear me okay there, Mick?
Yeah, fine.
Lovely. Okay. Good evening, everybody. I don't want to keep you too long. There's a nice waxing moon up in the sky now, so I don't want to keep you too long. In fact, I think it's sitting right on top of the star Pollux in the Twins of Gemini. Anyway, 12 years ago, in 2010, I took a series of photographs on the summer solstice of the sunrise terminator moving across the moon. And so I took a series of photos, and I thought it might be a nice idea to show them as a bit of a time lapse. So I worked with Tim Cole, talked to him, and of course, the way I'd taken the photos, nothing was registered in the same direction, so they're all pretty yin-yang. And Tim Cole did a fantastic job of kind of flattening each of the images so that we can work them to look at a bit of a time lapse. Now, I've got a bit of a bar showing across part of that. I guess that's part of the slide there. Okay, so we're looking at the lunar challenge for this time was Sinus Iridum, which is the Bay of Rainbows, which is set against the northern side of the much larger Sea of Rains, Mare Imbrium. So the little arced Sinus Iridum, the Bay of Rainbows on the left slide there that you see, it's about 260 kilometers across. We can go to the next slide, please, Dave. And we'll go one more. So this is the area we're looking at right in here on the moon. So in another couple of days, you'll be able to see the sunrise terminator moving across this area. And go again, please. So on that one evening of June 21st, this is the part of the series of photos that I was going to be taking, but I'm working with a slightly different photo here from a month earlier than that, just to show you the area that we were looking at. Now you see where in green, we've got the two promontories, Laplace and Herculides. So the sunrise terminator is coming from the upper right and moving to the lower left in this image. And we'll see the ring start to show up, and the ridge of mountains that forms the ring are the Montes Jura. Okay, we'll go to the next one. All right, so we'll go tap over on the right. You can see the crater Plato, Sinus Iridum is over to the left, and nestled in that other arc there, we see some mountain peaks sticking up out of the lunar regolith. The line of mountains, jagged mountains off to the right, that's Tenerife. One more to the right, Dave. Yep, that's Tenerife. The ones on the left, just where you were, that's Recti, Montes Recti. And those are actually part of the original rim of Mare Imbrium. Okay, so now let's go to the next slide, please. So it was the best I could do with, I was just basically hand holding a digital camera up to the eyepiece of an 11-inch Schmidt Cassegrain telescope. And go again. And we'll go again. And I think there's one more, eh? Or go again. Okay, try one more, what happens? Okay, so let's back up through those places, back up, and then walk through again. So it's just a nice way to observe something in just a few hours by observing the detail of watching the different mountain peaks light themselves up as soon as the sunrise is picking them off. We're starting to see more and more and more. Now, Mick, can you get that video to work, do you think? We've put these, Tim Cole did a wonderful job of putting all this together into a little video. I'm hoping we can make the video work. And I'll just mention while he's doing that for the lunar eclipse on May 15th, May 16th, you can actually observe the sunrise over Iridum coming from the opposite direction. So.
Okay, Brian, I'm not seeing a video embedded in the slides here.
No, it wasn't embedded. Mick we had to switch back to Mick. He said he had it separately.
Okay, so I'll stop the share, and then Mick, are you ready to go? You're muted, Mick.
Okay, and I need to share.
And if this looks like it'll take up too much,
No,
time.
here we go. We're good.
Okay.
Fine, great, and now playing. Certainly is nicer with those soft dissolves.
Yeah. Yeah.
Okay, one more.
One more, please. Thank you. Yeah. So, and watching this, you can watch this in just a few hours through your telescope. That's a nice way to watch it, or even with binoculars. You know, make a little note of where the terminator is hour by hour. Yeah. But like I say, during the thanks, Gordon. And thanks, Mick, for showing that, and Dave. Well, Gordon had a note there. So, and if during the lunar eclipse, when we see it, as the shadow's coming off, you should see this all light up in the opposite direction. Anyway,
Alrighty.
that's it from me. Thank you.
Okay, so back to you, Dave.
Okay.
Oh, hang on. It's going to be me anyway, isn't it?
I don't know. Let's see.
Okay, so over to the observations. We have a time-honoured tradition here at RASC Ottawa where anyone presenting for the first time gets first in the queue for presenting observations. And this case means it's me, and so I'm using the chair's privilege to remind you. About January last year, we had Loic Belmer-Alford do a presentation on cell phone astrophotography. And next one, Dave. Okay, so part of his presentation focused on the Google Pixel 4 and the inbuilt astrophotography capabilities of said phone. My own S7 had died, and I thought, what the hell? Went out, found a second-hand Pixel 4, and so wanted to grab an opportunity to see what it could do with its inbuilt capabilities, such as autofocus, exposure, setting, identifying foreground and background subjects, and its ability to actually generate stacks of 15 times 16 second subs. Also supposedly built into the phone was this opportunity for doing the stacking, white balancing, noise reduction, and differential exposures for foreground and rear objects, all driven by AI-based software in the phone. And here I was just shooting nothing. It was the first clear night forever. I went out to FLO for the first time in 3 years, set this thing up and had a play with it. And you can see the results. There's reasonably good star definition all the way down into the light dome from Ottawa, as seen from FLO. While there, someone pointed to the northwest and said, gosh, look at that. And lo, it was the train of Starlink satellites that had been launched the previous day coming up over the horizon. That's not my photo. But when I went and checked my phone, next one, Dave, there was my photo. And I thought, oh, wasn't that fortuitous? However, it gets better than that. What I learned was that the software in the phone is smart enough so that if there have been changes during the assembly of the stacked images, it actually renders a video. And so here is what I fortuitously captured of the actual rising train of Starlink satellites. And I thought that was pretty neat, and thank you for your attention. So back to you, Dave.
Okay, so we've got Oscar coming up here. Sorry, I've got to remember to highlight people here. You there, Oscar? There you are.
Yeah, I'm here.
There we go. Yeah, I can hear you. Let me just spotlight you. There you go.
Cool. All right, thank you. So this is an image of Messier 81, which is a spiral galaxy in Ursa Major, about 12 million light years away. Has a diameter of about 90,000 light years, so pretty close to the size of the Milky Way there. It's also known as Bode's Galaxy, which is named after its discoverer, Johann Elert Bode. This particular image was taken through my 8-inch Celestron Edge HD with a 0.7 times reducer with the ZW ASI 533 MC Pro camera, which is a one-shot color cooled CMOS camera. So this image is 94 3-minute exposures stacked together for a total of about 4 hours, 42 minutes of exposure. This was taken on March 29th. All right, this next image is Messier 96, which is a double-barred spiral galaxy in Leo, about 31 million light years away. It's about the same size and mass as the Milky Way as well. It's a rather asymmetric galaxy in both its arms and its central bulge. So this particular image is an LRGB composite taken through an 11-inch Edge HD at prime focus using SBIG STC7 monochromatic camera. All the sub-exposures were for each channel were 5 minutes long with 29 exposures in luminance, 36 in red, 35 in green, and 33 in blue for a total of around 11 hours of exposure. And this was taken on the nights of March 21st and 29th and April 21st. All right, and this last image is of Sinus Iridum. So I don't usually do planetary imaging myself, but I was recollimating my scope on a moony night. So I figured since I had the dome open and a camera mounted to the scope, I may as well try to make some use of the sky. So pointed it up at the moon and looked up what the lunar challenge was. So I pointed the scope at the target. So this was about 3,000 frames of video captured through an ASI 533 MC Pro. I stacked the best 10% in auto stackered, processed in Registax, and touched up a little bit in PixInsight. So this was taken on April 14th. The seeing was rather poor, so I'll leave it to you guys to establish whether the quality of the image is due to the conditions of the sky or the conditions of the astronomer who took the image. That's it for me.
Okay, good, Jim, Sophia. I don't see him on the call. So we will let him do his observations next month then. Don't look. Okay, there we go. Andrea.
Okay. This image is something that we call a deepscape, and it was my first attempt at this. A deepscape is an attempt to take a photograph of a deep sky object. In this case, you see Orion. This is the bottom half of the Orion constellation, Orion's belt and the sword. And you're combining it with a landscape. And in this case, it's the foreground of, basically it's Orion setting into the lake at Lake Huron. And this was shot with a full frame Nikon camera, which was astro modified, at 85 millimeters. And the key with a deepscape, so that it is true and not just a made up image, is that you have to shoot it from both the sky and the foreground from the same location using the same focal length. And at you have to have, obviously the foreground will be a static image, but I did do tracked images on a star tracker for the sky. And I believe these were 60-second exposures that I stacked for the sky. So this was my first attempt at this, and I was quite happy with it. Next, please. This is another image of Orion that I also shot. This was from the backyard in Ottawa, again with a full frame Nikon astro modified camera. I just got that camera astro modified. So I pointed it at Orion. And just so some of you may know, to have an astro modified camera means that a filter was removed from the camera, and then I put a hydrogen filter in the DSLR camera, so it's extra sensitive to the red colors and the hydrogen emissions. And so in this case, I was sort of aiming at Orion's belt, which are the 3 bright stars you see leading into the Horsehead Nebula. I obviously on the right, you see the Great Orion Nebula and a lot of the brown dust. And I didn't really mean to, but I caught M78, which is on the left side. And that's the 2 little bright speckles. It's a blue reflection nebula. Yes, thank you for pointing it out. And I got a little bit of Barnard's Loop. So that turned out quite well, considering it was the backyard in Ottawa. Next. Well, I meant to say that was with a wide angle telescope, a mini refractor. And you remember Jim Thompson talked about mini refractors before. This was my first attempt at shooting a galaxy through the big telescope that I have. It's a Celestron Schmidt-Cassegrain 11-inch SCT, and I used a 0.7 focal reducer. So this would be a focal length of almost 2,000 millimeters. And so that requires you to have quite steady tracking, which I kind of had, but not really. So this is the Messier 63. It is a spiral galaxy, and also known as the sunflower galaxy. I think maybe it looks like it has sunflower seeds. Maybe that's why it gets the name. And anyway, I just thought that was a nice galaxy. Lots of other nice galaxies you'll see tonight, no doubt, because it is galaxy season and there are certainly lots of galaxies to look at. Next. This was shot during the new moon in April, and it is the Zodiacal Light. And for some of you who may know what that is, the Zodiacal Light is the sort of triangular glow that you see in the image. And you can see it best in the northern hemisphere in the springtime after the sun goes down. So basically the sun will set and you can see a little hint of the sunset. And you'll see this glow, which will sort of point up to where the zodiacal planets, where they normally show up. You can see this as well in the fall, but you'll have to see it at dawn, just before the sun rises. And it has to do with the angle of the Earth and the sun and interplanetary dust, which is lit up. To see this phenomenon, you really need a dark, dark sky. And frankly, I saw it on the camera before I saw it in real life. This was a shot with a very, very wide angle lens, 14 millimeters on a full frame Nikon DSLR. And those were my images from last month.
Thank you, Andrea. Richard.
So you may remember in mid-April, we had some very strange weather with a hailstorm in the middle of the day. And even more strangely, it was clear that night. So the waxing gibbous moon with almost full was a nice target, but it turned out it wasn't so nice after all. The seeing was absolutely terrible. And within 5 minutes of my getting the telescope out, it was all fogged up. It was a very, very humid night after that hailstorm. So not a very good quality picture, but there's Sinus Iridum again. Next one. Now, here was the beginner's challenge object, the Galaxy M98. So at the end of April, we did have a nice string of some clear nights. And the first of those nights, April 28th, I was out at FLO and aiming at the challenge galaxies. This was a nice edge-on spiral, some interesting dust lanes just beginning to be visible there. Next one. I think that was not supposed to be the next one. This was my last one. This is the advanced challenge object. This is the Markarian's chain. of galaxies. This is the western end of the chain, and the big elliptical galaxy there is M86 with two more edge-on spirals bracketing it. And if you go to the next slide, yes, that points out all of the labels for these. There's so many galaxies in this region here. But the advanced challenge object was that little tiny wisp, IC 3355. And it's almost directly in between NGC 4402 and NGC 4435, which are part of the eyes, or Markarian's eyes. But of all of these galaxies here, I think the most interesting one is the NGC 4438, which is the other eye. And it has a swirl of very distorted stars all around it. So a fascinating area. And of course, Markarian's chain stretches eastward from here for quite a distance. So it's a really interesting area to point your telescope at. Okay, going back now to the intermediate challenge was NGC 4312, which is not the lovely big spiral. That lovely big spiral is M100, but it's the little edge-on elliptical. And if you go to the next slide, I think I've got it labeled. Yes, there we go. So there's the intermediate challenge, and bingo, I got them all this month. So that's all for me, thank you.
Do we have Bob Olson online here?
Yeah, you should have.
Yeah, there he is. You just down the screen here a bit from me. There we go.
Okay.
Now you're at the top.
Yeah, well, this is the challenge object M89. It's about 15 hours of exposure. Now, I didn't use it all because there was some moon and there was lots of wind. I have imaged M89 before, as I have actually imaged all of the Messier objects at one time or other. But when I went back to my 2009 image, I found that I hadn't processed it. So I have Oscar to thank for new data and processing. Quite an interesting galaxy, actually. Okay, next image, please. And this is my image of the challenge object 4312. And as Richard pointed out, it's kind of boring, but there's a really interesting galaxy in the upper corner there, which I sort of didn't know about before I started imaging 4312. And next slide, please. Yeah, and so as you can see, there's these two bigger galaxies, and I got bored after a few minutes of putting errors on the chart, but there's little galaxies all over the place. And next slide. Yeah, this is the 4312, which was the challenge object. And next one. As Richard pointed out, this is M100. And as I say, I have imaged all the Messiers before. So I went back and looked, and it was a 2011 that I imaged M100. So next slide, please. And this is my image from 2011. And you can see that the galaxy that was a challenge object I had imaged before, I just didn't remember. M100, and this was this was not taken with my imaging Newtonian, which is a 12-inch diameter telescope. This was done with a 3-inch Teleview and an old Sony chip that I have, a chip camera, which is really quite low noise. I actually like the chip. Okay, next one. And I imaged for I think 6 nights when we had that clear spell, and at the end of each night, I kind of was sort of bored with what I was doing, and so I just pointed at the Ring Nebula, which is one of my all-time favorites. One of the first objects I saw visually too, and so I actually got. Let me see, how many hours? I got. I don't know, 15 hours or something on this, or yeah, it was. beautiful image, and it has an awful lot of. It's 11 hours. 11 hours I see now. 11 hours of exposure, and it's a bright object to begin with. But boy, when you get 11 hours on it, it's pretty bright. Anyway, thank you very much. Have a good night.
Hey, good evening, everyone. Hi again. So this past December, I was out at the North Frontenac Dark Sky Preserve with Raymond Dubois. We went out despite the bright moon because it was actually predicted to be like a really clear night, and we wanted to be in good position to in a good dark spot also to see the peak rates after moonset. Moonset was about 3 in the morning. So we had a really good night. It turns out it was also one of the most mild mid-December nights, clear nights that I've seen in a long time during the Geminids. It didn't go colder than -4, so we were able to set up our gear, our cameras without gloves for a little while. And it was just a very pleasant night overall. So the rates were really good. Even with the bright moonlight, we were seeing better than 1 meter per minute. And after moonset, the rates were visually exceeding 100 per hour. So I had my 2 cameras. This is my old Canon 5D DSLR that I use with a 24mm lens. I was tracking the sky from about midnight until 5 in the morning, doing 30 seconds continuous exposures. So I ended up with several hundreds of exposures that I later in Photoshop I digitally stacked each meter together in the correct spot in the sky. And this is the result image with the brighter meter that you see in the shot was about a -4 Geminid. And you see Orion and Sirius in the shot as well. Next picture. My second composite, this was the ultra wide lens, 14mm f2.8 with Canon 6D, and also tracking the sky. Same length of time, so about 30 seconds exposure is continuous, running from about midnight all the way until 5 in the morning. And I wanted to aim on the radiant and have a good view of the surrounding sky all the way down to the horizon. And this picture, I believe I have well over 200 meters on this shot. A little hard to see, but right in near the radiant, there are some meteors that appear like little stars near head-on perspective Geminids. And in the shot, you see, because of the angle of lens, it's tilted. So Orion you see it a little bit sideways. And the M45 Pleiades cluster near the bottom side. So yeah, it was a very good night altogether. In the visually in almost 5 hours viewing time, I was able to see over 400 meteors. So it was a very active shower, even with the moonlight. And that's what I have. Thank you.
So I guess I'm up next. This is M51. We've heard a bit about this earlier today. This is obviously one of Charles Messier's objects. Okay, sorry, I don't know what I put a message there. This was actually interesting that this was the first really spiral nebula that it was ever identified by the Earl of Rosse using a 1.8 meter reflector in 1845. So it's interesting to see his hand drawing of this, and he even caught the companion galaxy. This is in Ursa Major, or near Ursa Major. It's in actually the hunting dog constellation. It's about 11 by 7 arc minutes, so it's actually bigger than most of the stuff I've been looking at lately. But it's because it's relatively close. It's about 31 million light years away from us. It's actually right around declination 45, I think. So it's actually tonight at 11:30. It will be almost exactly at the zenith for us. So it's a good time to observe it when it's that high in the sky. And as someone said, we're in the galaxy season. The M51 is at galactic latitude 68, which means that it's quite a ways away from the galactic plane. So when we're looking out at this galaxy, we're looking pretty much away from the galactic plane. So 90 degrees would be completely orthogonal to the plane, and 0 would be along the plane. So at 0 degrees, we'd be looking at Milky Way nebulae and all the junk and dust lanes and crop in our galaxy. But here we're looking way out. And so you get a great view outside of the Milky Way. So it's actually, you know, a bit like the Markarian chain that we just saw. There's lots and lots of small galaxies in the field of view. I'm just going to mention a little bit, like, because we're looking away from the Milky Way, we're looking at, in the foreground where you have a lot of stars in the Milky Way, and there, you know, would be, you know, sort of if you think of the thickness of the Milky Way plane, those stars are going to be around 1,000 light years away or less, probably. So when there, it fades out, obviously, so it's not exactly that. The M51, which is in the center, that is at 31 million light years away. So the foreground stars are, say, 1,000 light years, and this one is 31 million light years away. And then those other tiny galaxies are probably quite a bit more distant. So it's quite an, you know, I guess, quite a huge difference between the foreground stars and that galaxy. Anyway, within the galaxy M51, we see actually some pretty nice little stars along the spiral arms, and some dust lanes. And if you zoom, if you can actually zoom in, I can zoom in, you can't, I guess, but you can zoom into, say, the companion galaxy, and you can see nice clear dust lanes in there. And actually the galaxy's sort of overzealous in terms of star formation because of the interaction. So the small companion is actually receding away from us compared to M51, the main. So this is about 4 hours of observing with a RASA 11 at my cottage in Lac Tibbles.
You're muted, John. Okay, should be
can you
good
hear
now.
me?
Yep.
Okay, I'm surprised that people haven't been following the planets. That a year ago, some of my old high school astronomy friends, we still keep in touch. One of the guys challenged us to what he called a Mercury Marathon. You've probably heard of a Messier Marathon, but this was a Mercury Marathon. And I managed to get 9 observations. And again, this month, Mercury has been very well placed in the evening sky. So I've made 4 observations so far. The last one was last night, which was binoculars. It's starting to get into the twilight now. But hopefully you can see that this was about a week ago, was the Saturday night, I think it was. It was just about in line with the Pleiades. In fact, I had taken the picture. I could see it visually, but I wasn't aware the Pleiades were there until I actually put the picture onto my computer screen. So it's more or less aligned there. So that's the planet Mercury. And right now it would have been visible probably tonight. It'd be just setting about now, but it's rapidly moving into the twilight, and you would probably need binoculars, and it might be good for another night or two before it's disappeared completely in this apparition. Next one. Oh, that one was actually taken a couple of days earlier. They were out of order here. That was, I guess, the Friday about a week ago. And again, you can see them in line with the Pleiades. And I've been getting up early to see the planetary alignment. I got up at 4:15. I was out to my observing spot by about 4:30 a.m. And Jupiter and Venus off to the lower left were just rising. They just appeared around 4:40 a.m. So this is around 4:40 or 4:45 a.m. The furthest to the right is Saturn. In the middle, just to the right of that middle tree, is Mars. And then to the left is Jupiter and Venus. And in fact, that was a week ago, last Friday. The following night, Saturday, Jupiter and Venus were even more closer in conjunction. And my last observation was yesterday morning, Thursday morning, and now Venus has completely overtaken Jupiter. It's the one to the furthest to the left. And this alignment will be visible all month. And in fact, towards the end of the month, Mars is rapidly moving eastwards, and Mars will be in conjunction with Jupiter, a very close conjunction from the 28th to the 30th, just at the end of the month. And this alignment will continue on into June as well. And as you probably know, there's a very good opposition of Mars coming up towards the end of the year. So one more, is that?
That's it, John. Thank you very much.
Hi there, Dave. Is my audio good?
Audio is good.
Okay, super. I've turned off my video again to conserve my bandwidth. So good to go here. So good evening, everyone. I see that some of you certainly got out to enjoy the lovely span of clear nights that we've had recently. Wow, several clear nights of moonless skies with no snow on the ground, reasonable temperatures, and no bugs. Go figure, right? It's certainly been a while since we've been able to enjoy that. So last weekend, as John just pointed out, on both Saturday and Sunday mornings, we were treated to a beautiful close conjunction between Venus and Jupiter. On both mornings, the planets rose around 4:30 a.m., about an hour and a half before sunrise, and by 4:45 to 5 a.m., had climbed a few degrees above the horizon, enough to give us a good view under the still subdued light of the dawn sky. This view was taken with the planets about 1.5 degrees above my horizon, with Venus below and Jupiter above. The planets were separated by 0.5 degree, or about the width of the full moon, on both Saturday and Sunday mornings. At their closest approach, the separation was only about half this distance that you see here, but you would have needed to be on the other side of the world about 14 hours prior to this image to be able to see that very close encounter. This view and the following one were taken with my Canon 70D and a 300mm lens on a stationary tripod. They're single half-second exposures at ISO 3200 with the lens set to f4. Next one, please. So this exposure was taken about 10 minutes after the previous one, and in that time, the planets had climbed an additional couple of degrees, enough to rise above the thin clouds hugging the horizon, and that gave a clearer view. The image on the right is an enlargement of the view on the left and shows the 4 Galilean satellites of Jupiter, with Europa and Io to the left side of the planet, and Ganymede and Callisto to the right. Jupiter was shining at magnitude -2.1 on this morning, and Venus was a full 2 magnitudes brighter at -4.1. It was certainly a pleasant morning to be out there and enjoying this rather rare view. Okay, next one. So my remaining views of this for this evening all deal with the challenge objects that Oscar posed last month. Other than his lunar challenge, the beginner, intermediate, and advanced challenges were all concentrated in a spectacular piece of the sky between Leo and Virgo. This is the realm of the Virgo galaxy cluster, and we'll have a closer look at this. You can see why some of our seasoned sky watchers have already referred to this time of year as galaxy season. The area is just rich with objects for both visual observation as well as astro imaging. Even with a relatively small telescope, there are certainly many visible galaxies that you can enjoy in this region. Next one, please. So the Virgo cluster is the closest galaxy cluster to us and is believed to contain between 1,300 and possibly as many as 2,000 member galaxies. Its center is about 54 million light years from us. And the cluster is actually the heart of the much larger Virgo supercluster, of which our own Milky Way is actually a part of. So I took this image with just a 200mm lens and my Canon 70D on a Star Adventurer mount. The 6x4 degree field of view encompasses all of Oscar's Deep Sky Challenge objects, indicated here in yellow. In addition, there are numerous other Messier and NGC objects packed into this region. Just in this field alone, there are 8 of the 110 objects in the Messier catalog, with numerous other Messiers just nearby. It's certainly a rich hunting ground in this part of the sky. So we'll zoom in here and have a peek at the challenge objects, starting with Messier 98, then NGC 4312, and lastly IC 3355. Okay, M98, as you can see here, this was last month's beginner challenge and is a magnitude 10.1 spiral galaxy. It has an apparent size of 9.8 by 2.8 arc minutes. And in the field of view, you can also see the face-on spiral M99 and a pair of NGC objects in the upper left. The bright blue star between Messier 98 and 99 is the 5th magnitude star 6 Comae Berenices. This view was taken with a 420 millimeter lens at f7 and a Canon 70DA on an auto-guided star adventurer mount. It's a stack of 16 90-second exposures at ISO 3200. Next one, please. So for a closer view of M98, instead of showing you one of my images, I actually pulled this one from my archive of images from our old friend, Paul Commission. He took this image 12 years ago with the 14-inch scope that is now installed at FLO, and which should be ready for use by our members this summer. This is a single 10-minute image exposure that he did through that scope using a 2-power Barlow lens and a monochrome CCD imaging camera. So hats off to you, Paul Commission. Next one, please. Moving to our intermediate challenge object, NGC 4312. This is an edge-on spiral galaxy, a short hop away from Messier 99 down at the bottom right. It's last month's intermediate challenge object because it's only about half the size of M98 at about 4.6 by 1.1 arc minutes in size, and is a full 2.5 magnitudes dimmer at plus 12.6. The inset shows an enlargement of the full view. This galaxy is observable visually. You'll need at least an 8-inch scope to see it and reasonably dark skies. And it was discovered by William Herschel way back in 1787. I took this view with a 300 millimeter lens at f4 and Canon 70DA, again on an auto-guided star adventurer mount. It's a stack of 12 2-minute exposures at ISO 2500. Next one, please. Thank you. So our last challenge object is nestled among the showpiece of the Virgo cluster, as has already been mentioned. This is the Markarian chain of galaxies. If you get a chance to scout out the Virgo cluster, this is by far the highlight, and it's a must-see. Next one, please. The Markarian's chain is a magnificent arcing string of galaxies, some of the brightest galaxies in the Virgo cluster, and is visible even with a relatively small scope. I took this view with a 300 millimeter lens at f4 and Canon 70D, again on an auto-guided star adventurer mount. It's a stack of 13 2-minute exposures at ISO 2500. The advanced challenge object is certainly a challenge and just barely visible in this view, so we'll zoom in and have a closer look. And there at the top, my final image of this series is indicated by the little smudge at the top. It's classified as an irregular galaxy, and at magnitude 15.2 and a size of just 1.1 by 0.5 arc minutes, it's certainly a target for astro imaging, unless you have access to a scope about 20 inches or larger and very clear skies. So Oscar, you sure know how to pick them. It's challenging and it's a little faint fuzzy. Okay, so my final images for this evening are of last month's lunar challenge. You've already seen a few of these. This is spectacular. The Sinus Iridum, or the Bay of Rainbows. It's certainly one of the most stunning features on the moon. It is visible with a scope of any size and even in binoculars. It was formed from the remains of a large impact crater, which was subsequently breached and flooded by the molten lava flows that resulted from the formation of a mare embrium from an even larger impact by a protoplanet early in the moon's formation. So this is a view I put together. It's a stack of a number of AVIs that I shot with a 6-inch Maksutov Cassegrain using a 1.6 power Barlow, so an effective F ratio of 19.2. And using a DMK31 monochrome video imaging camera. This was an exceptionally clear night of seeing there, so the details were beautiful there, and you can see rich details of certainly in the crater Plato off to the right side of Sinus Iridum, and in Sinus Iridum itself, you can see the very rough terrain surrounding its unsubmersed side to the north of it. Next one, please. My last slide here is actually an enhancement of that view from a single AVI stack. This is 85 images from a stack of 500, and it shows just a tremendous amount of detail of the unsubmerged arc of the Bay of Rainbows. This is just a beautiful feature, especially near sunrise and sunset on this feature. You can see the very pronounced shadow, especially down at the bottom of the image. This is the prominence Laplace, and you can see the low sun angles really projects the actual shape of this promontory onto the flat plane of the flooded interior of the Bay of Rainbows. Also visible here are just a few small craters that have peppered the flooded lava plain, but the wrinkle ridges are lovely. It really to me looks like waves coming in on a liquid sea of water. But these are all frozen lava ridges, frozen in place long ago when the molten lava that was flooding this region started to cool off and solidify. So just a beautiful object to check out. And that's it for me tonight. Clear skies, everybody, and we'll see you again soon.
Thank you to all our observers, particularly for keeping to time. And now we get on to the observing challenges. There's our recap of last month's, as you've seen, well captured. This month's beginner challenge, M98, Spiral Galaxy, back in the same area of the sky as last month. It is galaxy season. So Messier 98 in Coma Berenices, 11th mag, 10 minutes by 3 minutes roughly. Next one. Intermediate challenge is NGC 4312, still in Coma Berenices, an edge on spiral at 12.5. Apparent magnitude.
These are last month's challenges, Mick. Oh,
sorry.
Those are last month's challenges, Mick.
Well, oh shit, they are too. I don't know how that happened. Can you flick to my screen, please, Dave? Okay, I somewhere along the track, okay. See, this is what happens when Chris isn't here. Chris knows all about this stuff. Oof, that's last month. Okay. Can we? Okay. Can you see my screen?
Yeah, we see your screen, but if you can do slideshow from current slide.
Yep. Alrighty. Apologies for that. Okay. So beginner's challenge for this month, not last month. M106. Spiral Galaxy in Canes Venatici, 8.4 magnitude, 18 by 7 minutes, 23.7 million light years away, and nowhere near Coma Berenices. Next one. Me. Thank you. Okay, intermediate challenge NGC 4651. Back to Coma Berenices, Spiral Galaxy, known as the Umbrella Galaxy, 11.4 magnitude and 72 million light years away. The advanced challenge, ARP 120, a pair of galaxies in Virgo. You saw some photos tonight in the shots of Markarian's chain, also known as the Eyes, NGCs 4435 and 4438. the Lunar Challenge, Crater Magenis, lunar impact crater in the Southern Highlands, roughly 200 kilometers in diameter, 4.3 kilometers deep. I might as well keep driving, Dave.
Okay.
So there's our summary of objects for the next month's challenges. Now, the good news. As of yesterday, we were informed by Andrea that public star parties are back on the go. Whether cooperating 4th of June at the parking lot of the Carp branch of the Ottawa Public Library will be our first public star party in over 2 years. So if you feel like a trip to nearby, just near the Diefenbunker, this is the place to be. In the top part of the slide here, you can see the Facebook and Meetup links wherein you'll get updates regarding weather, perhaps if we have to fall back to the fallback date the next night, this is where Andrea will let you know. And there's the overhead view showing the observing site, the way the car park's set up. There's also a set of guidelines available on our fabulously well-provisioned website, covering things like where you should park, what you should bring, what you shouldn't bring. In general, how to have a nice time at our public star parties. The Fred Lossing Observatory, FLO, back in business, continues to be in business. The only COVID-related news is that inside the clubhouse, the warm room, you are encouraged to wear masks. Otherwise, it's use your common sense. The next star party at FLO, scheduled for May 28th with a waxing crescent moon. Reminder that events at FLO are members only. Members can bring guests and are in course encouraged to bring their own equipment and set up early for a night of entertainment. With that, there's our usual gang of suspects, people to contact regarding things like FLO, the libraries, issues dealing with membership, and our subsidized renewals to magazines. I have no idea what our audience was tonight. I suspect it was about 80 at the top. Special thanks to all our presenters, and particularly our guest presenter, Ethan Siegel, and myself as host. Also to RASC National for providing these Zoom facilities. Everything you've seen tonight is available on our fabulously well-provisioned website. The videos, presentations, observations, the challenges, Astronotes is up there as well. Ottawa.rasc.ca. And yes, I know I fubbed the video of my Starlink train rising. That will be on the website probably tomorrow. Our next meeting, Friday, June 3rd, same time, same webinar back channel. Any ideas, suggestions, or contributions for observations to me, please, at meetingchair@ottawa.rasc.ca. And with that, unless there's anything that's come up, I don't see it. I wish you all a wonderful evening. Get outside and look at the waxing moon, and we will see you next month. Thank you.